Okay, boys and girls, we continue our lesson. Okay, last week, or not last week, 2 days ago. Okay, we stopped at the energy resources. All the theory part we already learned. Okay, for energy resources, actually is for us to generate electricity lah. Okay, generate electricity. How we generate electricity actually is how we turn the turbine, then turbine connected to the generator to turn the generator. Okay, why turning generator will generate electricity? This one is actually we will learn in year 11. Okay, year 11 we only learn about this. So right now our task is we have to think how we turn the generator. Okay, we got few methods. Maybe you can using the wind. Okay, wind blowing, then turn the turbine, turn the generator. Or we using thermal power station, we burn the fuel. Okay, for example, the coal, the oil, the gas. Okay, we burning, so we make the hot water become hot, the water turn to become steam, steam is moving gas. Okay, so it's turning the turbine, turn the generator. Okay, then this one is hydroelectric power station, is using the water, then water flowing down, turn the turbine, turn generator. Okay, tidal also water flowing, turn the turbine, turn generator. So wave, solar. Okay, geothermal. Geothermal is also make the water become steam, steam turn turbine, turn generator. Okay. Then for solar cell, so solar cell, the material actually can directly convert the sunlight, okay, convert to the electricity. So we're using solar energy, okay, convert to electricity. Okay, so at here we comes to the page number 6. Okay, this one is talking about advantage and disadvantage. Okay, so for the first one and two, these two are actually is non-renewable energy resources. Okay, that means that after we use it, no more already. Okay, we burn the coal, then no more already. We burn the oil, no more already. We cannot be reused. Okay, cannot be reused. Then for renewable to renew means that after we use up, okay, after we use, we still can reuse, okay? Will not run out. Okay, so at here, fossil fuel, we got coal, we got oil, we got natural gas. Okay, so for the advantage at here, actually, all these things we can get from the earth. So the source is free, it's cheap, not free, it's cheap. Okay, but most of the time when they're asking you about what is the advantage, okay, for this fossil fuel, we can say that small amount of this fossil fuel actually can produce a lot of energy. Okay, it can produce a lot of energy. So this is the advantage we're using fossil fuel, burning the fossil fuel to generate the electricity. Okay, what is the disadvantage? Of course, burning will cause air pollution. It will produce some gas that we don't want, polluting gas. So it will cause global warming. It will cause the greenhouse effect. Okay, so this one is cannot be replaced once it has been used. Okay, if we use no more it cannot be replaced. Okay, it's not like water, we can keep on using. Okay, so next another one is called nuclear energy. Please remember, nuclear actually is under non-renewable. Okay, nuclear is under non-renewable. Okay, small amounts of resources can produce a lot of energy. For nuclear energy, is much more powerful than this fossil fuel. Okay, so nuclear energy is very, very powerful. But the problem is it will produce radioactive waste. Okay, this one we need a lot of money to maintain and make sure that everything is safe. Okay, it's very expensive to build. Okay, because we need to make sure there is no radiation come out when the nuclear reaction is happening. Okay, so but advantage at here, it can produce a lot of energy and it can last a longer time. Here, this is a quite important point lah, when we always mentioning about the advantage of using the nuclear energy is it doesn't produce carbon dioxide. Okay, it doesn't cause the global warming greenhouse gas. No, okay, because this is not burning. Okay, it's not like we burn the fuel at here. No, nuclear energy last 2 days ago, I think I got mentioned. is a neutron hit on a uranium. This is uranium. Then it will split. The process will split into two daughter nuclei, then plus some neutron, okay, plus some energy, heat energy. So this one is the uh splitting process, okay, of the uranium. So it's not burning, okay, it's not burning, so it won't produce the polluting gas. It do not produce the carbon dioxide. So if they're asking you about advantage of nuclear energy, this is a very good point for us to write lah. Of course, produce a lot of energy. Okay, so same things. What is the disadvantage? Okay, cannot be replaced once it has been used. Okay, so one day it will be finished use up. Okay, has been used. Okay, then next is the renewable. Renewable hydro is related with the water lah. So water we store at the behind the dam reservoir. So water flow down, turn the turbine, turn generator. Okay, this is not a renewable. Okay, so the resources will not run out. Okay, so others also the same, will not run out, will not run out, will not run out if they are belongs to the renewable. Okay, all the renewable energy source, you can say that the advantage of the energy, you can just say that, oh, the resources will not run out. Okay, then for hydroelectric, low running cost, no fuel needed. Okay, reliable, do not producing polluting gas. Okay, because no burning. Okay, then here this is the disadvantage, will lose the habitat, limited site. Okay, not all the place you can do the hydroelectric, okay, power station. No, expensive to build, but when you running, okay, it's low, it's cheap because no fuel is needed. Okay, then for wind is resources will not run out. Okay, it's low running cost. But the problem is wind is not always available. Sometimes go wind, sometimes no wind. Okay, so this one is unreliable. Okay, unreliable. So next, deforestations will destroy the habitat. Okay, noise. Okay, one more is danger to the birds. Okay, the birds flying, then it might kill the birds. Okay. So for the wave energy, same, renewable, so resources will not run out, low running cost, difficult to build, unreliable. Okay, we cannot predict when the wave is moving. Okay, in unreliable. So the energy is not constantly supplied. The wave vary in size. Okay, every time the wave is in different size. Okay, so we cannot control it. Tidal, same. Tidal resources will not run out, low running costs. Okay, little environment impact. Also limited site, expensive to build, affect the transportation system in the water, affect the ecosystem surrounding the dam. So you just memorize like common sense to answer. Okay, no need to memorize every single point. So after today's, you have some idea what is the advantage and disadvantage for the power stations. So we're using common sense to answer it. Okay. Geothermal, geo is earth, thermal is heat. Okay, so at here resources will not run out, reliable. Okay, because the heat they produce is all the time available there, so it's reliable. Okay, then after that, potentially unlimited supply of energy, little impact of the environment. Limited site also. Okay, only works in the certain area only. Okay, then it's expensive lah. Okay, the process is expensive. So solar energy, resources will not run out, little environment impact. So solar energy, when you buy the solar cell, at first it's actually very expensive lah. So it's also unreliable because during cloudy weather, okay, the sunshine varies, so we cannot predict. Okay, unreliable. So for the hydro, this one is reliable source. Okay, it's more reliable. Anytime we want, then we can just let the water flow down. Okay, so this one, what else? Okay, should be fine. Okay, then here, so we goes to the exercise page number 7. No, not yet exercise. Okay, here the sun as the primary source of Zihua. Later I answer your question. Okay, here the sun as the primary source of energy. Okay, actually all these energy, okay, just now what we say electric the what burning the coal, burning the fossil fuel, wave, wind, hydro. All these actually is sun is their primary source of energy. Okay, so sun actually we got two energy, light energy and heat energy. Okay, the light will be absorbed by the plant. Okay, the plant here, so the plant will be eaten by the animals. So when the animal die, okay, it can be waste material from the plants and animal decompose and become biomass. Okay, so biomass power station actually starting is come from the sun. Okay, then the animal die and form fossil fuel. So also come from the sun. Okay, the plants die and form coal. Okay, fossil fuel. Okay, then for the light absorbed by the solar cell, so solar cell would generate electricity. Okay, so this one also come from sun. Okay, the primary source of energy is come from the sun. Then sun also provided heat energy. Due to the difference in the air temperature, we got wind. Okay, we got wind blowing. So wind blowing, we will generate wave. Okay, wave, water wave. So we got the wave power station. So here, rainwater is formed through evaporation and condensations of water. So at here, they have the water. After that, we store the water. Water flow down, turn the turbine, turn generator. Okay, so you will find out that actually they are starting from the sun because got sun, so they will have all of this. Okay, then here they have three. Radiation from the sun is the main source of energy for all our energy resources except three. Okay, do you know that which tree is not depends on the sun? Without sun, it still can continue running. Any of you know? Nuclear energy, yes. Okay, nuclear. So we write down nuclear. Then what else? Any of you know what else? Geothermal, yes. Geothermal is the heat from the earth. So it's not related with the sun. Without the sun, we still can have this geothermal power station still can running. Okay, one more, one more. What is that? Hydro, no. Hydro is here, dear. Hydro is here. Hydroelectric power stations. So water will form. We collect the water. So actually starting from the sun. So hydro is no. Okay, one more, one more. Do you know what is that? Okay, Angeline, let me have a look. Tidal, very good. Tidal. Okay, dear, I make a start at here is because this is a very important point. Okay, so this tree without the sun, this tree still can running. But others actually they depends on the sun. Okay, sun is their source. Okay, so at here 2016, which energy source is renewable and reliably available at all times? Can you try and then tell me? Okay, let me have a look. Wind, wind, wind. No, Zihua, no. Angeline, correct. Crystal, correct. Answer is B. Reliable all the time. Geothermal. All the time from our earth, we generate the thermal. Okay, renewable. This one is non-renewable, non-renewable. So nuclear is non-renewable. This is renewable. This is renewable. But this one is unreliable. Unreliable. Okay. So next, question number 2. Electricity can be generated using different energy source. Which energy resources is used to generate electricity without needing any moving part? Angeline, correct. Okay, what is the answer? Answer is C. Solar is actually from the sunlight. Okay, we use the sunlight straightly can convert it into the electricity. Okay, it's the material. So geothermal, we make the water become steam, then steam turn the turbine, turn generator, so it's moving. Okay, the turbine and the generator is moving. Hydroelectric is also the same. Water flow down, turn the turbine, turn generator. Water wave also at the end turn turbine, turn generator. Only C. Okay, only C without needing any moving part, it can straightly get the electricity. Okay, here number 3. Which type of power stations does not use steam from the boiling water to generate electricity? Angeline, correct. Crystal, Shuan, Zihua, no. Zihua, are you kidding me? Okay, how about others? Crystal, Shuan, Zihua, no. Zihua, you have to restudy again. Okay, does not use the steam to turn turbine, turn generator. Geothermal is using the heat. We heat up the water, water turn turbine, turbine turn generator. Nuclear also the same. Okay, splitting. After that, the energy will be heat the water. Used to heat the water become steam. Steam turn turbine, turn generator. This one, oil, burning the oil also the same. At the end, we heat the water, become steam, steam, turn turbine, turn generator. There's only one does not produce the steam, which is hydroelectric. So we just let the water fall down only. Okay, so answer should be B, dear. Okay, here number 4. In which power station are atoms of one element changed to an atom of other lighter element? Okay, so at here, what do you think? Which power station are the atoms of one element changed to atoms of other lighter element? Which one involved with atoms? Angeline, correct. Okay, here answer is C. Okay, let me check Zihua. Yes, nuclear, correct. So this one is the uranium. Uranium. Okay, we use a neutron to heat it, so it will split into daughter nuclei, new element, which is the smaller one, okay? Plus maybe 2 to 3 neutron plus the energy, okay? So this is nuclear, this is called nuclear fission, splitting, okay? Involved with the process of splitting. Okay, basically nuclear reaction we got two. One is called nuclear fission, another one is called fusion. But happen in our nuclear reactor actually is this. Okay, nuclear fission. Nuclear fission fusion actually in year 11 we will learn in the last few chapter. Okay, but right now we just need to know about nuclear fission. Okay, power station. The nuclear power station inside actually is nuclear fission. Okay, here, which list contains only energy resources that derive their energy from the sun? Okay, try. Angeline, correct. Zihua, yes. Any others? Crystal? Xuan? Okay, here. Derive their energy from the sun. Okay, except 3. 1, 2, 3. Except geothermal. So first answer confirm wrong. C, confirm wrong. Okay, what else? Nuclear also not depends on the sun, okay? Because it's a splitting process that we're using neutron to trigger it, trigger the process. Okay, nothing related with the sun. Okay, so solar nuclear no. So this one no. Nuclear. So basically after these two we already know the answer what B. Okay, one more is called tidal. Tidal is because the attraction between the earth and moon. Okay, so this one done. So can we proceed to the page number 9? Give me some reaction, dear Crystal. Okay, Angeline. Okay, let's go. 知话 okay. Okay. So I want you, without referring to the notes just now, our notes, okay? Can you try to think in which order is the energy transfer in this process? Okay. So what is the correct answer? A, B, C, D. Angeline, correct. Zihua, yes, correct. Okay, start. We need to have nuclear fuel, which is the uranium that I mentioned. Okay. Then it happened in the reactor and boiler. So the water will boil in the boiler will boil and become steam. Steam turn turbine, turn generator. So always generator is the last step. Okay, from here then we generate electricity. Answer is donkey. Okay, this is a common question in IG. So next, some of the energy is reliably available all the times, but some are not. Which row show three sources all in their correct column? Okay, try. Angeline, correct. Crystal, correct. Zihua, what do you think? Available, so it's reliable lah. It won't be affect. Okay. Zihua, no. Zihua, solar, sunlight not all the time have. At night we don't have the sun, so it's not available all the time. Solar no. So solar no. C and D wrong. Okay. Geothermal, yes. Geothermal, yes. Nuclear fission, yes. Okay. Nuclear fission is once we want it, then we just make the process to be happen using the neutron to trigger it. Okay. Not available all the time. Fission all the time, yes. So this one A is wrong. So solar not available all the time. Answer is B. Okay, answer is B. So next, number 8. Okay, which one is correct? So you read A, B, C, D, and then tell me which one is the correct description. Correct description. 子华 think again, 子华. Crystal think again. Crystal think again. Angeline? Oh, wait. 子华, you are right 嘞. 子华, you are right. 子华, you are right. Okay. Angeline, how about Angeline? What do you think? Correct. Okay, emit carbon dioxide. So hydroelectric no burning. So it will have no. Yes, correct. Then coal fire. So we burning the coal, it must have. Okay. Then it must have. This one also have. So B confirm wrong. Answer B confirm wrong. Then hydroelectric is renewable. Yes. Hydro wet. Yes. Then coal is the renewable? No. Then coal wire is renewable? No. Wait why got two answer? Hydroelectric power station is renewable. Yes. Emit carbon dioxide? No. Then the sea coal is non-renewable. Yes. Is a renewable? No. Yes. Correct. Emit the carbon dioxide? Yes. A. This is a two answer. Hydroelectric is renewable, dear. Hydroelectric is renewable. Zihua. Wait I check the past year question right now. Is it my typing wrong? Hydro is we store the water what? You give me sometimes I check the past year question. Is it my typing error or what? Yes, no, 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 yes, yes, yes. I didn't type anything wrong leh. It have two answer. Well, I see, dear. Yes, I typed wrongly, dear. Sorry, I know. This one should be a wind turbine. Wind turbine, my bad. Dear, my bad. Okay, my bad. It's a renewable, so this one is wrong. If wind turbine, so answer should be A. Okay, dear, make a correction. Okay, if just now according to my question A and C will be the answer. A and C will be the answer. Then I go back and check the past year. I found out that this one I might be like copy, then paste. That's why something wrong at here. It should be a wind turbine. Okay. Okay. So question number 8 answer is A. C here typing error. It should be wind turbine. So C can be cancelled out if the answer if the option is wind turbine. Okay, we go to your page number 10. Question number 6. Is it okay? Okay. Angeline, okay. Others not okay. Okay. Okay, dear, come here. Here are some statements about the energy and energy resources. Some statements are correct. Okay, 10 seconds, read it and choose. Okay, done? So here, building hydroelectric power station has an impact on the environment. Yes or no? Answer is yes, correct. Okay, correct. Then second one, burning fossil fuel produce atmospheric pollution. Yes or no? Yes, correct. Okay, wind turbine are turned using gravitational potential energy. Yes or no? No. Okay, no. Okay. We build it very high is because we don't want some obstacle so that at higher positions we will get more wind but not because of the gravitational potential energy okay. So here, the coal and the oil are source of renewable energy, yes or no? So yes or no? Coal and oil are source of renewable. No. Geothermal energy is obtained from the hot rock below the ground. Yes or no? Answer is yes. Okay. Most of the time you can refer to here lah. Most of the time, 3 mark should be three correct statement lah. But sometimes no. Okay. Most of the time yes. Okay. Okay. Here. State 2 energy resource for which the sun is not the main source. Crystal, tell me which state 2 energy resources for which the sun is not the main source. What do you think? Tidal and geothermal, yeah. Okay, one more. Tidal and geothermal. And nuclear, yes. Okay, third one. So you choose any two from here lah, any two from here. Okay, state and explain whether each of the following methods of electrical power generation is renewable. Okay, state whether they need renewable or not. Power generations in the nuclear power station is renewable or non-renewable? Statement? Non-renewable. Okay, explanation is because the nuclear fuel is used up. Once we use finish using, okay, no more already cannot be replaced. So this is non-renewable. Okay, power generations from wave in the sea. Okay, wave. So this one is renewable or non-renewable? Renewable. Okay, reason is wave. Never run out, yes. Okay, will always continue. Okay, so at here, answer scheme, they also accept wave produced by wind. Okay, when the wind blows, so the wave is generate. Okay, which will always continue. Here I say always continue is doesn't mean that it's reliable. It's not that anytime you want, it will have the wave. No, we cannot predict. We cannot generate the wind to make the wave, okay, produce the wave. No. Okay, here is it will always have the wind blowing, then we always have the wave. Okay, but we cannot predict when we have it. Okay? Or nothing use up. Okay. So 5 seconds, complete this part. Then we will go to page number 11. Okay, done? Crystal, okay? Silha, okay? Angeline, okay? Silha, okay? Angeline, okay? Shuan, okay? So we go to the page, next page, question number 8. Okay. Engineer working with the wind turbine. Okay, actually, this power station, this one, is a very, very big. So if person standing, person is small like this only actually. In real life lah, this power station is actually is very big. So human is only like this. Okay. So here, complete the sentence describing the how the electrical power is generated by the energy in the wind. The source of wind energy is, what is the source? Wind energy source is, no, it's not asking the advantage. Energy, wind energy, the source is come from, Angeline, correct, come from the sun. Okay, the source is come from the sun. Because of the sun, so in the process, then at the end we have the wind. Okay, when the blades turn, the electrical power is generated and in the where we generate the electricity. When we generate electricity. When we generate electricity, at which part we generate electricity? Angeline, correct. At the generator. We will always say turn the turbine, turn generator. Generator, inside the generator, we produce electricity. So electrical power is generated in the generator. Okay? Describe two advantages apart from the cost. Okay, so you don't talk about the cost of generating electrical power by using wind turbine compared with using a coal-fired power station. So what is the advantage of you using wind turbine? Why not using the coal? Okay, why we using the wind turbine? So give two advantage. Zihua, yes. Zihua first point said that because it is renewable. Yes, renewable. Wind actually is renewable. Okay, so the coal is non-renewable. Wind is renewable. So this is the advantage. Okay, after we use, then we can replace and continue using. What else? One more point. Zihua say it does not pollute the air and the surrounding. Yes, it does not produce the polluting gas. Yes, okay. So here, no air pollution. Okay, so you can also say that does not produce carbon dioxide. Okay, do not use fossil fuel. So don't talk about the cost. Okay, can we continue? Okay, next. Electricity is distributed from wind turbine to home and industrial. So statement A to F describe the main stage in the transfer of energy from the sun to the electrical energy in wind turbine generator. A and F is not in the correct order. Okay, 1 minute. Read from A to F, then after that you arrange it here. Then you tell me what is the sequence. Correct. Angeline, correct. Crystal, correct. Zihua, have you finished? Not yet. Okay. We give them sometimes. Few more seconds, faster. Zihua done, Okay, yes. So starting from C, energy from the sun. So this is number one, hit the atmosphere unevenly. So number two is D, uneven heating of the atmosphere produce regions of different atmospheric pressure. Number three is A, the air move from regions of high pressure to regions of low pressure. Number three. Then after that, next, what is this? F. Here is F. Moving A will turn. Number four, moving A will turn the turbine blades. Number five, turn turbine, then we will turn generator. So it's B. Okay, generator produce electricity. Okay, so this is number 6E. So can you see that way we generate our electricity is in the generator. Okay, year 11 we will learn inside the structure why and how generator can generate electricity. So this one answer is C, D, A, F, B, E. Okay, no matter how, generator will be the last step. Generator then produce electricity. Okay, here. Step two disadvantages. Apart from cost, don't talk about cost. Using wind turbine to produce electrical energy for homes and industry. Okay, two disadvantage. So just now this question is talking about advantage. Now we're talking about disadvantage for the wind. So what do you think? Okay, let me check. Yes, Angeline, correct. Let me check 子花. 子花, yes. One more. Crystal? 子花, you give me two same answer what? Crystal, do you have any idea? Okay, here. Okay, here. Uh, wind is not always available. Yes, okay. Wind is not always available. So, or here we can say that sometimes cannot work if the wind is too weak. Okay, or you say wind is not always available. Also correct. Deforestation, yes. Wind not always available. Yes, correct. Okay, here, what else? Larger area of land needed. Okay, what else? Energy output is small. Okay, why we say that larger area is needed? It's because if only one, the energy that we produce is very, very small amount. So in order to generate enough of the amount of energy, okay, so we need a lot. Okay, a lot. If you a lot, then we need a large land for us to build the wind power station. Okay, so at here, what else? Number four, yes, just now you got mentioned about noise pollution. Okay, one more, we can say that harm to birds. As I told you, actually this one from the diagram we cannot know. It seems like this one just a very small wind turbine, but no, actually this wind turbine, if the human standing, it's just so small. Human is so small. That means this one is very high. Okay, the bird will flying and then hit by the blade and then die. Okay, that is the problem. Okay, so for this part, just step two. Okay, here I give you more answer lah. Okay, so if no problem, we are going to the last page for this lesson number 20. Any question? Angeline, no. Only Angeline. Okay, here. So boys and girls, here 子华 okay. Okay, here, this is a hydroelectric system for generating the electricity. What sort of energy processed by the water in the reservoir? Okay, what type of energy? What do you think? At here, at start, water have what energy? Angeline, correct? Gravitational. It have a certain height, okay, certain height. So due to the position, energy due to the position is gravitational potential energy. So 子华, this one, here, come back to the hydro. Here, starting is gravitational potential energy. So water stored, okay, in the reservoir. Okay, it has GPE. So 子华, this one, okay. Okay, come back here. Okay, here, when the water flow down the pipe, it is moving. What sort of energy does it possess because of this movement? Water flow. Water moving. Kinetic, yes. Kinetic because moving. Actually in the exam past year paper it doesn't bold like it lah. Okay, this one is I bold it for you because I want to tell you because of this keyword. Okay, so here the water will turn the turbine to rotate. So what sort of energy do the turbine have because of their rotation? Turbine rotate. So what kinds of energy it has? Crystal, no. Rotate. Crystal, rotate. 实话 no. How about Angeline? Angeline, guess. Chemical? Rotate is chemical? No, dear. Kinetic, yes. Rotate is moving what? So this is kinetic. Okay, kinetic. So we come back to this, dear. We look at here. So here, water store and then water flow is kinetic, right? Okay, if in between we want to add one more point from kinetic, actually it's another kinetic, also kinetic. But this kinetic is because of the turbine and because of the generator turns. Generator. Then after that goes to electrical. Why I only put one is because I include these two kinetic energy together lah. But basically, if you want to talk in more detail, is we store with a certain height, so we got gravitational potential energy. Water flow, so we got kinetic energy. Water turn the turbine, turn generator. This is another kinetic energy because it's turning. Then at the end, we generate electricity. Oh, let me have a look. Can be reused. It doesn't mention using the words from the list. It doesn't mention. So yes, can be reused, dear. Okay. What sort of energy does the power station generate? This power station want to generate what energy? This power station want to generate what kinds of the energy? Yes, Crystal, electrical. At the end, we generate electrical energy. Okay, electrical energy. None of the energy transfer process is perfect. In what form is the most of the wasted energy released? What do you think? 实话 correct? Crystal correct? Engineering correct? Internal heat. Okay, here, option, this option, internal energy. Okay, internal actually is not only kinetic energy, but also have the gravitational potential, not gravitational, it's potential energy and kinetic energy. Kinetic will producing the heat, but mostly internal energy is due to the kinetic, so mostly is the heat thermal energy lah, okay? So at here, wasted energy, most of the case, we will always say that energy lost to the surrounding uh, due to the friction and it converted to the heat. Okay, so this is heat is our mostly is our answer lah. But of course, some of the applications such as like kettle, you cannot say heat is the wasted energy. Kettle, we boil the water, make it become hot. Then heat is not the wasted. Okay, so have to depend on the case lah. But most of the case, actually wasted energy is in the form of heat. Okay, until here, any question for these energy resources? Any? No, okay. We still no. Then we goes to the next chapter. Okay, chapter 8, work and power. Okay, work is done when a force makes something to move. Okay, work is done when a force makes something to move. Work is defined as the product of force and the distance in the direction of force. Product means what? Product in physics means times. That means that work, W equals to force times distance. Okay, force times the distance. And then here you have to be careful. The force and distance direction, they are in the same direction. That's why here in direction of force. Okay, the S distance and the force, they are in the same direction, parallel. Okay, parallel. So at here, SI unit of work is, okay, any of you can tell me what is the SI unit? Zihua, correct. How about you derive from the formula? Crystal, first one correct, but how about distance, unit of distance? Let me check. Zihua, no. We got per meter leh. We are times what? So unit for the force is in Newton. Unit for distance is in meter. So at here, what is the SI unit for work? It should be Newton meter. Okay? But we also can just say that it is joule. Okay, after that we will learn. Work done is actually energy transfer. So what is the unit for energy? Is in joule. Okay, it's in joule. Kinetic energy in joule, gravitational potential energy in joule. Okay, work is a scalar quantity. We don't care about direction, doesn't matter. Okay, work is energy, energy is work. So energy is scalar quantity. Of course, work is also scalar quantity. Okay. So at here, we comes to here, okay. We can solve the problem by using two methods. We can using work done or we can using gravitational potential energy when the weight is lift, okay, we lift the weight, okay. So for this case, these two object we lift up, okay. So at here 200 Newton weight. So W equals to Fs. So this is the formula for us to do calculation work done, right? Okay, how much force you need to apply moving it up? This one object pointing out, the weight is pointing downward. Weight always pointing downward. This is 200 Newton. In order to lift it, you also need 200 Newton. Get it? Okay, so from here, we lift it up to a new position, 0.5 meter. So you see, this is my direction of force. This is my distance. I move up. So this one distance S and my force in the same direction. So here the force that we need is 200. The distance that we need to move it up is 0.5. So at here answer should be 100 joule or 100 Newton meter. Okay, so this is we calculate it using the work done. Okay, so how about GPE, energy? So can we using GPE, energy, GPE? Formula is mg h. Do you know what is the mass? What is the G? What is the h? We know that h is actually 0.5. It moved up 0.5. But how I going to solve with this part? Mg. Any of you know? In the question doesn't provided the m. How can we solve? Crystal, very good. Mg is what? Mg is weight. W equals to mg. Mg is weight. So this part actually is the weight. So weight is 200 Newton. Then we lift it up is 0.5. So we also get 100 joule. So I can make a conclusion say that work done actually is energy transfer. Work done is energy, energy is work done. You can use either method, you will get the same answer. Okay, you will get the same answer. Is that clear? Sometimes they didn't give you the force, they didn't give you the distance, but you can find the work done by using mgh or using kinetic energy formula to find it. They will be the same. Okay, so is that clear? Can we go to the page number 2? Crystal, okay? Zihua, okay or not, Zihua? Yes, okay, let's go. Okay, work is done. Okay, first case, I will look at the case A. You look at this. Okay, we push 120. This is my distance, move 50 meter. Because they are in the same direction, so work is done. Yes. Okay, we look at C. Force is applied, you move it upward, okay? Then it will leave, it will move upward, okay? You push, this is the force direction, and the distance that you apply is in the parallel way. So this is the work done, okay? This work is done, okay? For A and C case. So no work is done is, oh, what is this? Idea, this one, DO and E. I change. Alamak. Okay, here force is applied, but there is no change in the distance. Let's say today I ask you, hey, can you help me move the wall? If you're able to do the work, you do the work, then I will pay you the money. But at the end, no matter how you push, the wall is still there. So should I pay you the money? No. Okay, I won't pay you because no work is done, dear. No work is done. Okay. So how are you always have so funny picture? Okay, here, dear. This one. Okay, force is applied perpendicular to the distance. Okay, let's say you carried a baby. So of course you holding. So your force is moving upward. Okay, in the upward direction. This is your force. Okay, you're holding the baby. Then you walking like this. Did you do a work? My answer is no. No work is done when you carry the baby. Okay, so you should like this, same direction. Or maybe you carry the baby, then you move up, down, then yes, you do the work. Okay, so this one, the force and the distance is perpendicular, so no work is done. Okay, so let's go at here. A 500 Newton weight. Newton is the force, is the force, or we say weight. It's raised through a height of 5 cm. How much work is done by the force? W equals to Fs. So can you try and then tell me your answer is A, B, C, or D? Angeline, good. Because there is something want to trick you and you know you need to do some conversion. Kristen, no? Kristen, did you do some conversion? Okay, here, force is 500 Newton. Force is the weight is the force, okay? So at here, you know that the work done is in joule. Joule is a SI unit. So when you get the final answer in joule, that means that this one must be in SI unit, which is in meter. Then how about your distance? Your distance at here must be in meter because meter is our SI unit. So you must convert 5 cm to meter. 5 cm convert to meter. Your prefix is here, cm. Okay, C is your prefix. So it's 5 times 10 power of negative 2. C is times 10 power of negative 2. Or you, very common, your mathematics, you know that 5 divided by 100. Okay, 5 divided by 100. So at here, 5 times 10 power of negative 2. Your answer should be 25 joule. Crystal, I think you didn't do conversion. That's why you cannot get. You do conversion less 1, 0. Okay, divided by 100, dear. Okay, let's go. Goes to the page number 3. Okay, can we go to the next page? Okay, let's go. A toy car is pushed a distance 2.4 meters. So this is the distance. With a force equals to 460 Newton, how much energy is transferred? How much energy is transferred? So what is your answer? Correct, Angeline. Energy. So the car moving. So this what is the energy? It's kinetic energy, am I right? But teacher, 1 over 2 mv square. They didn't provide me the speed. They didn't provide me the mass of the object. Then I cannot count. Is it? No. Yes, we can't count 1 over 2 mv square. But we know that energy is actually the work done. Okay, energy transfer is actually equals to work done. We cannot using 1 over 2 mv square count. It's okay. We're using work done to do calculation. F times S. So your force is 460. Your distance is 2.4. So it's already in meter and in Newton. So we can straightly get the answer. Answer is 1100 joule. If you press your calculator, it should be 1104. So at here, two significant figure. In your IG, two significant figure. 2 to 3 lah, okay? But MCQ will find out that most of the time it's two significant figure. Okay, for this one, the main idea that I want to bring to you is energy transfer is actually work done. They ask about energy, not necessarily must be using mgh or 1 over 2 mv squared to do calculation because some of the information might be not given. Then what should we do? We can using work done formula. Okay, so goes to question number 3. A moving object is brought to rest by resistive force 50 Newton over a distance 5 meter. What is the work done by the force? Angeline, correct. Crystal, correct. Okay, frictional force is always oppose your motion to resist your motion. So at here, 50 Newton, that means that you also need to apply 50 Newton. Okay, in order to overcome it. Okay, so at here, W equals to Fs, 50 Newton. So you move 5 meter. So 250 joule. That's all. Okay, goes to question number 4. A car has 620 kilojoule of kinetic energy. The car brakes and stop in a distance of 91 meter. What is the average braking force acting on the car? Zihua, no. Zihua, no. Angeline, correct. Crystal, do you able to get the answer? So kinetic energy. Then I need to find the braking force. It moves with a distance 91. So how are we going to find the force? By using the energy. Because energy transfer is actually, this is for last question. This is for last question what? It's okay. So energy is work done. So what is your energy? This is 620 kilo. Don't just using the value. Don't forget about the prefix times 10 power of 3 equals to force times distance is 91. So what is your force? Your force is actually 6800 Newton. Answer should be C. Is it okay? Energy transfer. What energy you have? 620 kilojoule. Okay, Crystal okay already, so we can go down. A builder lifts 30 bricks from the ground onto a platform 2.0 meter high. Okay. So here the height is 2.0 meter. Okay. So we carry the brick. Something like this. Okay. Times 30. We got 30. So we move to a certain height like this. Okay, next. Each brick have mass 4.0 kg. What is the work done against gravity? Like there, against gravity. Against gravity, where is your gravity? Gravity is pointing downward. So that means that pointing downward. So you want to against the gravity, that means that this one move up. Okay, work done against gravity by the builder in lifting the brick onto the platform. So what do you think? Crystal, Crystal, no, Crystal, you miss out something here. Crystal, can you tell me what formula you use? Then I can guide you from your formula. You almost there, almost there. I know what is missing. Angeline, correct. Zihua leh, Zihua, what do you think? Do you able to count? No ah. Correct, Zihua, correct. You use force time distance ah. Okay, like this. Crystal, you using work done is force time distance. Okay, what is your force? What is your force? Crystal, your force is it? Let me have a look. 4 times, okay, 4 times 30 because 4 kg, then we got 30. Am I right? But this is called mass. This is mass M. So your force should be times 9.8 mg. This is the mistake. Okay, this is the mistake. Then here distance is 2. So at the end, your answer should be 2,400 joule. Okay, this is the correct answer. Okay, another way is still against gravity. It lift up, am I right? Lift, okay, lift. So keyword here is lift. So when lift, what kinds of energy? Energy is GPE. So we can also calculate GPE equals to mgh. So what is your M? Your M is 4 times 300 is your mass. Then G is 9.8. Then your height is 2. So answer is 2400 joule. So can you see that, dear? W equals to Fs, W equals to mg. Actually, your answer and substitution is exactly the same. It's exactly the same. So if you didn't using W equals to Fs, you can using the mgh to do calculation. Total mass times the G times the height. Okay, so C at no C, it's D. Okay, can we go to the page number 4? Crystal, okay. Angeline, no problem. Okay, Zihua, okay, Zihua? Yes, okay. A horizontal force pull a box along a horizontal surface. The box gains 30 joule of kinetic energy, and then 10 joule of the thermal energy is produced because of the friction between the box and the surface. How much work is done by the force? What do you think? Angeline, yes, correct. How much force is done, how much work is done by the force? So think, how much work need you to do it? Zihua, let me have a look. No, Zihua, no. Crystal, Crystal. Zihua cannot accept. Okay, so it move. So kinetic energy is 30 joule. Okay, energy transfer is kinetic energy 30 joule. Then in between, we got 10 joule losing to the surrounding. So what is the force that how much work you have to do in order to having this effect? Okay, so that means that if you want to do the work, you need to apply 40 joule. In this 40 joule, got 10 joule is lost to the surrounding, only 30 joule is useful. Okay, so your answer for this, how much work is done actually is 30 joule plus losing to the surrounding. So you should do 40 joule of work. Okay. Okay, the energy transfer, kinetic energy plus the losing. Okay, next slide there. A car of mass 500 kg, so this is the mass, it's moving with a speed 10. The engine does work on the car and the speed increase, so this is a final. How much work is done by the engine to increase the speed of the car? So think, how much work is done in order to increase the speed from 10 to 16? Angeline, no? No? You direct minus, I know, you direct minus from starting. But no, actually you should count for each of them, the energy for each of them. Then after that, it will only minus. You cannot at start, you already minus the speed. I give you guys a hint, energy at here and energy at here. I say this is final, this is initial, okay? So you will find out that this one, of course, need a higher kinetic energy, this one lower kinetic energy. So how much work you need to extra do to increase the speed? So you should calculate the energy separately, then only minus them. Any of you able to get the answer? Work done is 1 over 2 mv square minus 1 over 2 mu square. Final kinetic energy minus the initial kinetic energy. So how much extra work we need to done actually is from minus, okay? Final minus initial energy. Angeline right now correct. Okay, so 1 over 2, 500. Your final is 16 square minus 1 over 2, 500. Initial is 10 square. So at here, this one extra work need to do is 39,000 joule. Answer should be C. You cannot straightly minus first, V minus 10, then you only count the energy. No. You have to count final energy because you see formula is V square U square. So you cannot minus first, okay? Using calculate the energy, then you do minus after you get the energy. Zihua, don't ask me. Okay, Crystal, is it okay? Wait, okay, no problem, you wait. Okay, there we go to the next. This is the theory test on your understanding. We want to lift a box, okay? Which action involve the woman in doing the least amount of work? So you read it and then you tell me what is your answer. Crystal correct. Yes. Zihua correct. Okay, what is the answer for this? Least amount of work. This one we leave. Keyword here is leave. That means that this is involved with the MGH. Okay, so energy of GPE, which is MGH. Okay, leave the box quickly. That means that time shorter. So our formula, no matter E equals to mgh or W equals to Fs, we didn't involve with time what? So for the answer A and B is wrong. We didn't involve with time. Doesn't matter. You leave fast or slow, doesn't affect amount of work that you done. Okay, for example, I give you homework. Okay, homework for you, go back and complete it. I don't care you complete it within 10 minutes or you complete it using 1 hour. Doesn't matter. At the end, did you complete the work? And that is amount of work that you done. Oh, you complete the 3 homework. That's all. Okay. So time is not a problem. Not the things that we need to consider for the work lah. Okay. Lifting the box to low here. Okay, low shaft. Then after that, lift to the high. So that means that in total, actually, this is the height that you lift. Okay, then D is lifting to the low. Okay, last one, D is actually the height is here. We lift until here only. Okay, so that means that the hatch is a lower hatch. This one is higher hatch. So answer should be donkey. Or if you're using the distance to explain, so it will be a shorter distance and longer distance. You travel a longer distance and shorter distance. So at here, your work done is less. So this one is your energy is smaller energy. So answer should be donkey. Okay, we goes to your page number 5. Is it okay? Okay, here. Each spring has the same stiffness. Oh, we already learned about Hooke's law, right? Stiffness is actually how hard the spring can be extended. So if your K value F equals to Kx, do you still remember Hooke's law? So this is spring constant. Spring constant, if your K is high, that means the spring is stiffer spring, okay? So same stiffness, that means that you need to apply same amount of force to extend same amount of extension cm. How many cm is you using the same force? Okay. Okay, A, B, C, D. Which case does the most work? Angeline, yes. Zihua, yes. Okay, so what is the answer? Answer is donkey. Why? W equals to Fs. So you got two spring. You need to stretch the two spring compared to only one. Which one you need apply more force? Of course, the two spring here, you need a more force. F more. Of course, then you ask, hey teacher, why not C? C also got two spring what? But here, the distance is stretched is actually higher, larger distance. So answer should be donkey. Okay. Then we goes to the case number 10. A box of mass M slide down a slope of length L against the frictional force. Okay. It descends a vertical height D. As the box slide down the slope, it loses GPE and it does work against the friction. Which rho give the loss in GPE and work done against the friction? So what do you think? Zihua already want to sleep? No. So what do you think, guys? 10. A, B, C, D. Angeline, correct. Loss in mgh, what value we need to use? mgh, mgh. So m is here, g is here, height. So the weight is pointing downward, what? mg is pointing downward. So your height must be same direction as this one. The weight same direction as your distance. So you should using mg, using d as your height, okay? So work done against friction. Where is your friction? Okay, I highlight it here. This is your friction. So same direction should be this distance, okay? So W equals to Fs. to against the friction, so the force must be the same force, same magnitude of force, but opposite direction. Okay, so F times S. What is the distance it travel? Is the L, blue color. So F dot L. So answer should be C. Hey, wait. MGD. So A. FL. Yes. Okay, answer is A. Is that clear? Can we go to the page number 6? Crystal okay, huh? Ziha okay. Angeline okay. A box of mass M slide down the slope. Oh, wait. Okay. This sentence cancel. This sentence cancel. This is the last question here. A box of mass. Okay, two men X and Y try to move identical heavy box PQ. Okay, two men X and Y try to move identical heavy box P and Q. The man X try to push the box P along the floor. The box does not move because an object is in the way. Man Y lift the box Q from the floor. Okay, so which man does the most work on their box? And which box gains most energy? Angeline, yes, correct. Zihua, correct. Okay, here first case, man X. Man X do work or not? What do you think? Crystal, yes, correct. So boys and girls, you push. But then the problem is the box does not move. That means that no distance, S equals to 0 here, does not move. S equals to 0. This case is something like just now I told you, the wall. Then no matter how long the time you push, how much effort you push, actually I won't pay you any money because you didn't do any work. So for this case, work is 0. Okay, this one, work W equals to Fs. You apply the force and then you move it up. So this is the distance. S. Okay, so yes. So this one should be the man Y. The box gain most energy. This one no work done, so the box also no energy. So this one, yes, should be Q. So answer should be donkey. Okay. You must pay us my no, I won't. Okay. Like dear here. Figure 5.1 shows a child pulling a toy trolley across the floor. Okay, the child pulls the toy trolley with a horizontal force 12 Newton. The distance moved by the trolley is 5.0 meter. Calculate the mechanical work done on the toy by the force 12 Newton. Okay, what is your answer? When you go higher level, for example, you goes to air level, this is the force that we apply, right? Then this is the distance we travel. This is the object, then we travel for a certain distance, okay? So at the end, this is the distance. For example, this one like this. In air level, what I tell you. Okay, we move it. So this is the distance. So if like this, how can we calculate the work done? We cannot because they are not in the direction. Okay, in the same direction. So in air level, in one day, if you study physics in air level, so you need to resolve the force from this F, resolve it to become Fx. Then you only can apply Fx times S. But now we are in IG, okay, O level, so they straightly give you Fx, 12 Newton. Okay, when you go higher level, they will give you in others direction, then you have to resolve it, okay? So here, this one is actually very straightforward. Angeline correct, Crystal correct. So 3 marks, no matter how, we need to have the habit. Okay, W equals to Fs. The force is 12 Newton, travel 5, so it's 60 Joule. Okay, 60 Joule. Okay, we go to the page number 7. Is it okay? Next. 1 more minute. Calculate the weight. Calculate the weight. Crystal, make it two significant figure. 2 to 3. Angeline, okay, can be accepted. Yes, okay, W equals to mg. So at here is 3.2 kg, not in gram. If in gram, you have to convert into kg. Why? Because weight is in Newton, is SI unit. So your mass must be in kg. Maybe they will give you 3200, okay, I don't know, gram. So you have to convert it, okay, then times 9.8. So answer for me 31 Newton or 31.4 Newton. 2 to 3 significant figure. Zihua, don't write 31.40, 31.4. Okay, they're here. Last question. The student carry the books from the bottom to the top of the stairs. The vertical height is 4.5. Show that the work done on the books when they carry to the top is approximately 140 joule. Can you do calculation? And show that work done is actually 140 joule. Do you able to solve? Work done is force times distance. Force that you apply upward equals to the weight. Okay, this is the weight. So that means that you need to apply same amount of force upward. So the force that we need to apply is actually mg, which is our weight. Just now our weight, we do calculation and we get 31. Am I right? Distance, same direction. Same direction. The distance should be this, 4.5. Okay, so 4.5. So my answer should be 31 times 4.5. So 139.5. So it's 140. Is it okay? 31.4 times 4.5. Oh, okay. Okay, determine the gravitational potential energy gained by the by the books. What is the GPE? Gains by the books. Can you give a reason for your answer? Last already? Lydia, give me the answer. Kristen, no. Zihua, yes, why? Zihua, why? Angeline, yes. Reason is yes. Zihua. Okay, yes, correct. Deal, your gravitational potential energy should be 140 joule. Why? Because, let me check. Because work done is actually gain in GPE. Work done is energy transfer. So the amount that we calculate for the work done 114 joule, it will be the same as the GPE. So energy transfer is work done is energy. Is that clear?